The digital twin service includes a variety of components. One of them is the power modeling service, based on Jupyter Lab notebooks. Here we can appreciate how the circuit looks like in a graphical representation. However, the circuit is stored as a map power file and loaded with a library specially developed within this project. In this example, we use the harmonized data from the I-NERGY project to make a simulation using the data ingested from the pilot. Each measurement set gets simulated, and with that we obtain the powers and voltages on each one of the nodes in the circuit. We made contributions to the open-source project DPSim because it is used as the main component that executes each simulation step in the loop. This takes some time because we are now selecting a period comprising 1 week. Here we can appreciate the voltage in node N4, where there is a PV system associated that generates changes during the daytime. We can also change the selection to see other results.
Here we will observe the interconnection to the forecasting services. The main objective here is to obtain the data forecasted for a next-day horizon, and to prepare it for the simulation. The retrieved information in this case is for 2 of the measurement devices of the set. The other 2 are retrieved by using averaging methods coupled to a lookup table strategy. This means that the procedure allows to have a value that is closely related to the past events in the electrical circuit. The retrieved measurements then are bundled together for every one of the time steps, and then the whole set of measurements gets saved to be processed again in a simulation cycle. This integration is made possible by the close cooperation between the service partners across work packages and the pilot, who is the data owner.
With the previously saved data forecasted measurements, this proof of concept shows what can be achieved for the future of the distribution networks. The knowledge about the electrical circuit and the parameters, coupled with the precise forecasts of the loads that include distributed energy resources like photovoltaic systems and electric vehicle charging stations, can be simulated 1 day ahead. We see here the simulation results with a good time granularity of 15 minutes. And the execution time here is not high as the data points correspond to 1 day. We can appreciate again the behavior of the node N4, we see the characteristics of solar energy systems. The results for other nodes, for example N3, can also be analyzed.
Lastly, we see here the viewing and monitoring service. The user can have a more friendly way of interacting with the system, when all the parameters are already configured and no more modifications need to be done. After the initialization phase and when all the systems are ready, the user can select the dates where he wants to perform the simulation, in a similar way that he would do in the Jupyter Lab. The simulation setup is then done, and by pressing in the button Run Simulation, it runs in the background on the server side. The user may need to wait depending on the time frame selected. Due to our time limitations in the demo video, we fast forward to a time where the simulation results are available, and we click on the Insights tab. We can now select our simulation timeframe and then the individual results and even combine them. This know-how can be used to further exploit the results of the projects in new digital twins. Thanks for watching. For more information, contact RWTH Arkan.